Okay, geometry with equations. I'm going to do a few examples. Basically, what's going to happen now is it's going to be a geometry question. But in order to find an angle or a variable, you're going to have to set up and solve an equation. Right. So it sounds very complicated, but it's actually not that bad. Let's write, it's just going to take some practice. That's all. Let's just write examples. And it's nothing new, guys. We have all the knowledge now that we're going to have to apply for this. We just need to practice putting it all together. All right. So that's why I'm not doing a note. We're just going straight into examples because you already know everything that you should know in order to do these things. Guys, remember the thing with geometry is a lot of content that you need to know. So if you have not paid attention, I think you guys did really well in that geometry progress. Okay, and I think also last term we managed to sort out the triangle stuff. But yeah, if you don't know what corresponding angles are, or what alternate angles are, or you don't know what the sum of the angles in a triangle should be, then you're going to struggle with this work. All right, because you haven't taken the time to memorize and to learn all of that stuff. Okay, so the first one, determine the value of x. And then we're going to draw a picture. It's not a very complicated picture. We just have a straight line. And this is now putting together all the geometry that we've done for this whole year, guys. You have to know all of it for your test. Drawing a picture that I'm doing. All right, determine the value of x. Everyone trying to finish doing that. We have a straight line, and then there are three angles there. There's a 20-degree angle, 150 degrees, and then x. Now guys, also, usually I have to write it now, but usually when you are given geometry questions, they'll say the diagrams are not going to scale. Okay, so you can't like take your protractor and measure what that is and then divide it by 2. Okay, you have to work with the actual rules and stuff. But this definitely isn't a 130-degree angle, right? So we agree. 130 is supposed to be obtuse. And the way that it's drawn here, it almost kind of looks like it's obtuse. It's maybe like an 85 or 88 or something. All right, so we don't go for how it looks. We need to work with the values that are actually given. Okay, guys. Angles on a straight line. Add up to 380. Now, in the past, what we did, we all agreed that I have to find this angle, right, in order to find x. They want us to find the value of x, not 2x, but I do need to find this angle in order to figure out what 2x is. So in the past, what we would have done is we would have said 2x is equal to 180 minus 20 minus 130 degrees. Right? What is the reason for that? Angles on a straight line. Did we write SCR in it? Okay, now before we get out in x, let's simplify this. Remember when we're solving an equation, do you agree that this is an equation that we're solving, right? We need to find what x is. We have to have variable numbers. Okay, so I don't want 3 separate numbers like this. Let's just work this out. 180 minus 20. And 60 minus 130 is 30. So 2x is in fact 30 degrees. That means that this whole angle here is 30 degrees. Now what am I doing with this 2 on this side? Multiplying. When I get rid of it, the opposite of multiplying by 2 is dividing by 2. So now x is going to be 30 degrees divided by 2. You can write it over 2 or using the division symbol. So what is my x value? 30 degrees. Anyway. All right, number 2. All right. Sorry, it's not seeing it's going to see. Okay, in the diagram, AB is perpendicular to BC. What does that mean? So what? Yes, okay, perpendicular, that symbol means perpendicular. That means that where they meet, where they intersect, a 90-degree angle is formed. Okay, so I'm going to write there 90 degrees. So AB is perpendicular to BC. So guys, we can pull that in actually on the diagram. Remember that that is the symbol for perpendicular, for a 90-degree angle. So just draw a little box there in the angle. So how can I now use that information to solve for it? Calculate. That 90-degree angle is made up of what? 2x and 3x, right? So can't I just say 3x plus 2x should be equal to 90? Okay, 3x plus 2x is equal to 90 degrees. And guys, the reason for that, you can actually just write what they wrote here. You can just say that that angle is 90 degrees because AB is perpendicular to BC. There isn't another reason like in words, like we have for the other. Okay, we can just say AB is perpendicular to BC. 3x and 2x are those like terms. Can I add them? Yes. What is 3x plus 2x? 5x. So 5x is equal to 90 degrees. What am I doing with the 5 on the left-hand side? Currently, I'm multiplying. So what is the opposite of multiplying by 5? Dividing by 5. Good. So x is going to be equal to 90 degrees divided by 5. Which is what? 18, I think. 90 divided by 8, I'm just, sorry, divided by 5, sure, why did I think 8 now? 18, yes. Okay. Number 3. Are there any questions on that one, guys? Is it awful? Right? It's not, I don't know. It's not that bad. I don't think it's that bad. Wow, that's great. Quick geometry. And you guys are doing it. Well done. Geometry and algebra together. Could you ever imagine this last term? No, man. Right? And now you're doing it. Okay, we have that. We have 65 degrees here. We have x plus 25 there. And we must find the value of x. So we have the 2 straight lines that are cutting, intersecting, vertically opposite angles, right? And what do we know about vertically opposite angles? They are equal. Okay, so there we go, guys. That's not too bad. This angle, x plus 25, is equal to the angle that's opposite, so 65 degrees. Reason, vert of angle equal. Sorry, I just want to make that look like an owl. There we go. So we've staked up an equation now. That's what we've done here. Now we need to solve the equation. So we need to find what x is. What's the opposite of adding 25? Subtracting 25. So that's what we're going to do on the other side. So we're going to say x is equal to 65 degrees minus 25 degrees. And what's that? 40 degrees. So x is 40. So guys, we need to know our geometry in order to set up the equation, right? We need to know that vertically opposite angles are equal. So that line is using geometry knowledge. And then after that, we need to know how to solve an equation in order to get that right. Okay. Number 4. Okay, let's focus, please, guys. We all need to be copying this down. Sorry. Okay, are we ready? Okay, guys, now we have parallel lines, right? Do we agree? Those arrows are telling us that those 2 lines are parallel. Let me actually, it's not labeled in the book, but let's just do this correctly. Let's label them, sorry, A, B, and C, D, and then we can call that E and F. Okay, now guys, we can actually find X and Y in each order here. They haven't really specified. I do feel like if they say X and Y, they are kind of telling you to do X first and Y next, right? But yeah, if they don't really specify, it's not the end of the world. So let's find X first. Do we notice that Z shape? Yes. Remember with alternate angles, sorry, with parallel lines, we need to think about alternate angles, corresponding angles, co-interior. Okay. In the previous questions, we didn't have parallel lines, so we didn't even think of those. All right. Now, as soon as we see parallel, we need to think Z shape, F shape, or C shape. Okay. So we have that Z shape, so that means that these two angles have to be equal to each other because those lines are parallel. Okay, so we're going to write this angle x plus 15 degrees is equal to 60 degrees. And the reason for that is alt angles. Which two lines are parallel? A, B, and C, D. Right, what's the opposite of adding 15? Okay, no. Adding 15 is subtracting 15. So we are going to say 60 minus 15, which is what? 45 degrees. There we go. So equals 45. Okay, now to find y, we could actually do two different things. I'll show you now. Guys, whenever you are working with multiple variables, we now know that equals 45, right? Is that true? We get started. So we can actually work out what this whole angle is. X plus 15. What's 45 plus 15? 60. So you can fill that in, guys. You can calculate it when we have the actual value of x. You can use that to get that whole angle. So now there are two ways in which we can find y. Yes. Angle on a straight line, you've noticed that? Angle interior, right? Both of them will have the exact same working, exact same answer, but different reasons. Yes? Corresponding. You have to have, so 3, so you would have to get that one first. Do corresponding. Okay, but you could. And it would just be an extra step. Alright, so guys, let's do that calculation. So I'm going to say, remember, let's just go over that again. Angle on straight line add up to 180. So because that is 60, I'm going to say 3y is 180 minus 60 degrees, right? Remember me? Yes, okay. 3y is 180 minus 60 degrees. Angles on a straight line. Or for interior angle, your working would be exactly the same, guys. You would have that same first line. So look at that option now. A, B, parallel to C. Go back to the picture now to show you how that works. For interior, that's the C shape, right? So I'm looking at the shape over here. Oh. Okay, so these two must add up to 180 as well. So you would again say 3y is 180 minus 60. Same working, just different reading. Okay, so you can decide which reason you want to write there. It's basically whatever you see first, you write down. Okay, what is 180 minus 60? Okay, what am I doing with the 3 over here? Multiplying, good. So on the other side, the opposite of multiplying by 3 is dividing by. Yes, so y is 40 degrees. Okay, we're going to do some triangle examples now because we haven't really worked with triangles a lot recently and they can take you on it. Remember what did I say? All the geometry that you've done this whole year can be in your text. Okay, so example 5. Are you guys all done copying that down? I have to go. Yes. Okay. What's that now? Number 5. All right, guys, thank you. You're supposed to be copying this down, please. I surely must know that. Literally, I've been looking at you the whole time. How much of the energy that I'm spending on you guys could be going to the whole class so that everyone has a phone. That's your guys are selfish. Okay, we are drawing a triangle. You don't have to draw an isosceles triangle, but you know you can maybe try. So it's okay if it doesn't look like one. Okay, guys, if they give us all 3 angles in the triangle. Okay. Got all 3, we could say that's what that equals. But what value? 180. Right. Angle from a triangle, yes. But we only have 2. Is there a way for us to find that third angle, that angle at C? Okay. Well done. Angles opposite equal sides. Right? So we agree that triangle ABC is an isosceles triangle. Right? Those 2 sides are equal. Now remember that means that the angles opposite those 2 sides will also be equal. Okay, so that's x plus 5. This is also going to be x plus 5 degrees. You have to write that down, guys, as a statement. So you're going to say angle C is equal to x plus 5 degrees. Angles opposite equal sides. There will be a mark for that line, possibly even 2 marks. Okay, one for that, one for that. If you don't write that, guys, you can use up to 2 marks. Okay, it's important. Now we can use angles and triangles because now we have all 3 angles. we say that we have these angles in terms of x. Have you heard that like sentence before? In terms of x. That means that all of these angles have been written using x. Alright, they didn't say this is 60 degrees and that is something and that is something. They've written the three angles in terms of x. Yeah, that's what that is. That's term. Alright, so now we're gonna say 4x minus 10 degrees. That's angle A. Plus angle B, which is x plus 5. Plus angle C, which we also said is x plus 5 degrees. So those three angles, right? That's angle A, that's angle B, that's angle C. You can write it just underneath if you want, as a reminder of where this is coming from. Is equal to 180 degrees. And the reason there, someone said it earlier, is angle sum in triangle. Okay, sorry, my apologies. And now this is an equation that we must solve, hey? They say we must solve the value of x and we must solve for x. As I suggest, like I said yesterday, because we have lots of terms here, 6 terms to do that, let's just simplify what's going on this side first. Okay, it will make the doing the opposite operations a bit easier. So let's look for all the x's. We have 4x plus x plus x. That is 6x, yes, correct. Okay, and now let's look for the numbers. Negative 10 plus 5 plus 5. That's 0, okay? So you can put a plus 0 there, but you don't have to. You can actually just say 6x is equal to 180 degrees. Okay, you don't have to write that plus 0 there. You can just write that line if you want to. 30 degrees, right? Well, how do I get to 30? What does I do with the 6? What's the opposite of multiplying by 6? Dividing by 6. So x is going to be 180 degrees divided by 6. So x is in fact 30 degrees. All right, I'm going to give you guys some questions to practice on your own now. There we go. Okay, revision. Grade 8, for those of you that has a different textbook, this is topic 10's revision exercise. So you might just have to find where topic 10 is and then go to the revision exercise. And then exercise 11.2. Which you'll also just have to look for. I'm not sure what page it will be on. In mine it's on 108, so some of you will have a different page. Yeah, just number 3 of that one. And then for the next one, I would like you to do 1 and 4. And then the next one. No, or even the topics different. Oh dear. Okay, sorry. So it's actually not even topic 10. It's geometry of straight lines. So topic 12. Sorry, it's topic 12 in the other book. And then is this going to be 13.2? Okay. Oh, but now I want it. Oh my God. No, sorry, I'm just adding like 7. Okay. Guys, I'm just gonna put this first exercise on the board quickly because it might be different. I just want those of you that have a different book, right? You can just write this down quickly, everyone, so I can put the question on the board. Right, and I'll just check with you. Yeah. Okay, guys, those of you that have the other book for 3B, I'm going to draw it and then you can just take a picture of it. Don't do 3B that's in your books. Do the 3B that I'm drawing. Only if your exercise is not on page 101. If it is, you just do the exercises on the page. Okay, if you have a different book, remember there are 2 versions of this book, then you're just going to have to take a picture of this. Ooh, that's really wobbly. Yeah, usually. Sorry, maybe let me just make that a bit smaller so that it's easier. Yeah. So this exercise, Freya, is what page? 143. In the other book it's on page 143, that one. What does it say? Oh, it's in front of your eyes, number 3. Okay, guys, that is the 3B that I want you all to do. These are your 3B from the revision exercise. Looks different to this one. You're going to have to take a picture of that, please. Then, Fred, can we just look for this exercise? Go to 11.2. Mine's actually 13.2. What chapter? What topic is that? So you're looking for topic geometry and 2D shapes. And it looks like this. So next one. That one. What page is that? Is it 11? Yeah. Okay. In the other book, guys, this exercise, the second one is on page 116. I just want to check that they're the same. I'll do it after that. Sorry. Number 1, 5, 5, 4, 6, yes. Number 4. Yes, and then number 7. Okay, guys, the second exercise, everything is the same. So just those of you that have the exercise on page 143, you're gonna have to do this one for free. Please, not the one for free. Thanks. Next email. I know what I think if they don't mistake that, we would say that's it. But no, what happens if I don't the answer 1.8 if you would say 1. Yes. So you will say x plus 20 equals the 20, then you're gonna minus the 20. I feel like you have some. You see, I know what I was trying to teach you.